Medieval siege engines were marvels of engineering, towering machines built to crush fortifications, shatter enemy defenses, and strike from afar. On the battlefield and during sieges, different machines played unique roles, each with its own strengths, limits, and ideal conditions. Some were built for range, others for precision, and a few for sheer, unstoppable power. We'll now explore how each of these legendary weapons worked, their design, their physics, and the genius that made them so deadly. The trebuchet, the king of medieval siege weapons. A masterpiece of balance and gravity, it hurled massive stones using nothing more than the pull of the earth itself. Its principle was simple, but brilliant. The potential energy of a falling weight transformed into the kinetic force that launched a projectile. Its structure featured a sturdy frame, a long throwing arm with two unequal sides, a pivot, and a sling for the stone. A massive counterweight hung from the short arm. When released, it plunged down, pulling one end of the lever and flinging the other skyward. The sling whipped forward, releasing the projectile in a smooth, powerful arc. The dimensions were carefully calculated, too long an arm, and the stress could snap the axle, too short and the shot would lose range. Stones were selected with care. Smooth, round ones flew truer and farther. Unlike torsion weapons, the trebuchet didn't rely on twisted ropes or temperature-sensitive materials, making it more reliable in damp weather. Its drawback was speed, reloading took time. Crews had to hoist the heavy counterweight back into position using winches and pulleys. But what it lacked in rate of fire, it made up for in sheer might. A single well-aimed shot could pulverize a section of wall. Sometimes, crews launched not just stones but flaming barrels, rotting carcasses, even jars of poison, anything to break the enemy's will. The trebuchet's greatest strengths were its predictability and its devastating impact. Defenders tried to destroy them with fire or quick raids, but these wooden giants often dominated the field. Before gunpowder, no machine matched its power. Modern reconstructions show that even a medium trebuchet could hurl a 30-kilogram stone over 200 meters, a terrifying display of medieval physics. It remains one of the most recognizable and awe-inspiring symbols of siege warfare. Now let's turn to a very different kind of weapon, precise, swift, and deadly accurate, the ballista. The ballista, a colossal crossbow forged for war. Designed to fire giant bolts or spears across vast distances, it was the sniper rifle of the Middle Ages. Powered by twisted cords or taut sinews, it stored immense tension between two arms joined by a string. At release, that pent-up energy exploded forward, sending the bolt screaming through the air. The ballista's advantage was accuracy. Its shots followed a straight, deadly line, perfect for cutting down troops or enemy crews. It could pierce armor, shatter shields, or ignite chaos among advancing ranks. Unlike trebuchets, ballistae weren't just for offense. They stood guard atop walls, towers, and even ships, raining precision death on attackers. Each bolt was a crafted weapon in itself, often tipped with iron or filled with fire. The torsion ropes, twisted from sinew or strong fibers, had to be kept in perfect condition. Too dry, and they snapped. Too damp and the power dropped. Maintaining a ballista was as much art as science. Crews of several men worked in rhythm, drawing, loading, aiming, and releasing, each shot a display of coordination and nerve. Faster to reload than a trebuchet, the ballista could fire repeatedly, holding back enemy waves. It was difficult to build and delicate to maintain, but in the right hands, it was unmatched. For its blend of range, accuracy, and speed, the ballista was the most refined siege weapon of its era. Next we move to something more flexible, a machine that balanced power with mobility, the catapult. The catapult, smaller than a trebuchet but quicker, lighter, and easier to move. It used the power of twisted cords, torsion, to fling stones, burning pots, or any payload of destruction. Catapults offered the perfect compromise: good range, decent accuracy, and rapid fire. Their crews could maintain a steady bombardment, keeping pressure on defenders day and night. But torsion came with risk, humidity, wear, or a single misstep could weaken or even tear the ropes apart, sometimes with deadly results. Compact and versatile, catapults could be pushed close to walls or mounted on siege towers. Well-trained crews monitored the tension, checked the arm, and adjusted the throwing angle for maximum effect. They launched firepots, oil jars, or rocks into enemy positions, sowing fear and destruction. When used alongside trebuchets, catapults provided relentless mid-range bombardment, breaking defenders' morale before the final assault. They were quicker to build, easier to transport, and perfect for prolonged field sieges. Though less powerful than trebuchets, their versatility made them one of the most common siege weapons of the later Middle Ages. And when the time came to breach the gates, that's when another machine took center stage, the battering ram. The battering ram, simple, ancient, and brutally effective. It was nothing more than a massive log capped with iron, swung back and forth to smash through gates or weak walls. To protect its crew, the ram was often housed in a wooden shed with a roof and walls, the tortoise or boar. Inside, dozens of men pushed and heaved together, driving the ram in rhythm until the gates cracked and splintered. The heavier the beam and the wider the swing, the stronger the blow. Iron heads were sometimes forged into the shapes of beasts, focusing all the force at one deadly point. Rams worked best when other machines kept defenders distracted, trebuchets pounding walls while the ram crept toward the gate. But they were dangerous to operate. Stones and boiling oil rained down from above. Defenders countered with grates, trenches, and iron-reinforced doors, buying precious time. To withstand fire, the ram's shelter was soaked in water and covered in raw hides. When the gates finally gave way, the assault troops charged and the ram's work complete. It was crude, heavy, and slow, but when used right, it could decide the fate of a fortress. As gunpowder weapons rose, the ram slowly disappeared, but it remained a timeless symbol of raw power and courage. A machine that demanded strength, discipline, and unity from its crew. Siege warfare was as much about brains as brawn. Each machine had its purpose, and victory depended on how well they worked together. The trebuchet shattered walls. The catapult weakened defenses. The ballista silenced enemy crews. And the battering ram delivered the final blow. Teamwork was everything. A single mistake could cost weeks of effort. Engineers and craftsmen constantly checked ropes, replaced parts, and shielded machines from moisture and fire. Defenders answered with sabotage, fire attacks, or water to ruin the enemy's torsion ropes. Some even built decoys to trick the besiegers' aim. Good reconnaissance and terrain analysis decided where to place each engine. Bad calculations meant wasted ammunition and lost time. Logistics were crucial. Heavy beams and counterweights had to be transported and assembled under constant threat. Even weather, wind, humidity, and heat could change the outcome of a siege. As gunpowder and cannons appeared, these mighty machines slowly vanished. Yet their legacy endured. The same principles of stored energy, leverage, and force live on in modern engineering and weaponry.